Hey, this is Don from Padlock Technologies here with another video. We are going to talk about hierarchical VPLS, or virtual private LAN service. This is a more advanced technique when it comes to routing because it's still technically VPLS, but you have two new components to it. So we're going to talk about theory first, and then the next video I'm going to put out, it's going to be a lab. So you actually get to go from theory to practical in the next video. So you know I like to do my titles. Let's go with the hierarchical VPLS. So a hierarchical VPLS, it allows you to do a layer 2 emulation service in different domains. So the same setup is true for things like unified MPLS or seamless MPLS, where you can have separate domains, but still have layer 3 VPNs go across those different routing domains in a hierarchical style, right? So the two new things in VPLS here is going to be a thing called an NPE and a UPE. Now the UPE is closer to the client or the client's router, the CE, and the NPE is in the middle. So what that would look like is like this. So NPE, a couple NPEs, NPE2, NPE3, NPE4, right? Now let's say you have those connections there, like that, right? And then you have UPEs out here, UPE1, UPE2, UPE3, and UPE4. Now you also have those connections. Build your triangles out like this. All right. All right. And then from there, you have CE, 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 CE. Now, when you see the lab of this, and we'll just say 1, 2, 3, 4. Now, when you see the lab of this, this is the actual design that I'm going to build. Now, the difference here is you're going to run VPLS in the middle, right? Technically, it's going to be VPLS in the middle, and it's going to be manual. So it's not going to be auto discovery. You're not going to use BGP for auto discovery. You're not going to suppress LDP, which is technically the Capella method. Martini method is using LDP for signaling and for signaling the neighborship and signaling of the VC label. But we're not going to do this here. So this is going to be manual. And then these other domains here, let's say this is domain here, and we'll use blue over here. This is domain here. This is going to be, I would say this is going to be X Connect. So you're technically running VPWS, VPLS, VPWS, if you want to think about it, right? And you're still going to be able to reach each PE. This is going to look like a big switch in the middle. It's going to emulate the switch. These will all be in the same subnet. And then you can run routing, say in the lab, when I show you the lab, it's going to be EIGRP, and there's going to be a neighborship at each of these CEs, and you're going to see full reachability, right? Now, why would you do this? Again, this is more of a service provider thing, but if you're talking to your service provider and they're offering you something like this design, they may call it something different. They might not even tell you it's hierarchical VPLS, but that's technically going to do what it's going to do. And now you can add different pops or point of presence, can technically hook into the main area of the main core area from different pops and still emulate that layer 2 service or layer 2 emulation across the service provider core. So when this is all said and done, it's going to look like these CEs or these routers. When this is all said and done, it's going to look like they're technically next to each other, right? Or in the same layer 2 segment or attached to the same switch. Because all of this here is going to look like one big switch, right? Still going to be running LDP all the way through. That's going to be for your labels. But then if you try to do a trace route from say this this CE to this CE, it's only going to look like one hop, right? Because technically here are called attachment circuits. And this is for, I believe I said this in another video, for overlay VPNs. This is overlay VPNs. Layer 2 VPNs are overlay VPNs. Layer 3 VPNs are peering VPNs because you're peering with the PEs. With this, you're not peering, right? So there's no state in the middle of this, right? Nobody, you don't know anything about this. If you're doing a layer 3 VPN, there will be some state, but only at the edge. And then the P routers in the middle just need to know how to get to the edge routers, right? Dummy core intelligent edge is MPLS in a nutshell. But these attachment circuits will have VC labels or it's not going to be called the service label. Service label is technically for L3 VPNs, but VC label, virtual circuit label, is going to, get attached to traffic here. Then you're going to have your transport layer. Remember, VC label or service label, think of it as the client. So think of this as the passenger, right? So VC label, it's going to be the passenger. Transport label is the bus, right? Transport label is the bus. This is MPLS in a nutshell to get from PE to PE. This is ultimately the traffic this is the label on top of the traffic, and this is going to be the bottom of the stack label. All right, bottom of the stack label, which technically in MPLS, if you watch any of my other videos, if you look at MPLS as a whole, you're going to have 20 bits for the 30 for the actual label. Then you have 3 bits for the experimental bits, which is the QoS stuff, right? QoS. Then you have a 1 for bottom of the stack. This says this is the last label in the stack, so there's no more label. There's going to be data, and then 8 for TTL, right? And when you do that number together, it's 32, right? When you do it all together, that's MPLS in a nutshell. But the forwarding decisions are based on this label, right? So 20 bytes versus a 32-bit lookup. When you're doing normal routing is a 32-bit lookup versus MPLS, which is a 20-bit lookup. That's why this is considered faster, right? And you don't have to worry about have to know about the destination. You just need to know how to get to the PEs. But that's a whole different MPLS conversation. So this is hierarchical MPLS. It's not MPLS, VPLS, which is basically layer 2 emulation in separate routing domains. So this routing domain is OSPF, 1, right? And this is going to be in a lab. This is going to be ISIS. And this is going to be 49000 as the area, 4 zeros. And then this is going to be OSPF 2, ASN 2, right? So now you can see where you're not going to have, reachability or topology information because you're running 3 separate routing domains. This is the same concept with unified MPLS or seamless MPLS. Same concept. Separate routing domains now in unified MPLS or seamless MPLS, you're going to use BGP all the way through to not only do the VPN v4 table and all that stuff, share that. Now there will be a route reflector somewhere in here. Usually the route reflectors are going to be in the middle here with these NPEs, but there's no NPEs in unified MPLS. This is totally getting off topic, another side quest. But you would have route reflectors here. You do BGP, and now BGP will also not only do the VPN v4 MPLS L3 VPN. I don't know why I paused right there, but it will also send the labels, right? So you're going to be sending labels with BGP. And if you don't know, let me just tell you right now, there are 4 ways to actually do labeling in, MPLS. It's just labeling, period. So there's LDP, there's RSVP, and this is if you're doing MPLS TE, traffic engineering, which is source-based routing. There is BGP, right? And then there's this thing called SR, which is segment routing, which is a whole different technique that kind of encompasses a lot of things. It gets rid of LDP, ultimately. It gets rid of LDP because it allows you to do the labeling in the IGP. So a lot of people are moving from traditional MPLS, LDP style stuff with segment routing. Now there's a whole different thing that you need to worry about, because you have this thing called prefix SIDs and adjacency SIDs. And then you can do something in here called TILFA, right, which is topology independent loop-free alternatives, right? So that gets into P nodes, Q nodes, PQ nodes, and all that other good stuff. And I don't want to start rambling and side questing on that. I want to stay just on hierarchical VPLS. So this is what you're going to see in the lab. Basically, in the next video, you're going to see this design. You're going to see 3 different routing domains. You're going to see, you know, VPLS in the middle, then technically VPWS, or virtual private WAN services. And then you're going to see how the bridge domains are connected. You're going to see, I'm going to show you how all my adjacencies on my CEs, you're going to see all 4 adjacencies from an EIGRP perspective, and you're going to see connectivity, right? I think you're going to like that lab. If you're kind of interested in this, send me another question if you want to go a little bit more into detail of how this works behind the scenes. I hope this video was informative. Thank you and have a nice day.